When we import a CAD part in *CCM Plus and also while creating parts inside *CCM Plus, there are a lot of unwanted features in the CAD like holes, protrusions, chamfers, fillets, bolts, fixture shapes, etc. These are not important from CFD point as their size is small and they do not affect flow distribution compared to the overall CFD domain. The disadvantage that these unwanted features have is in generating mesh. Due to the complex shape and breakage that they create from main CFD volume, it is difficult to maintain mesh continuity unless we create a very fine mesh for these features. If we create a very fine mesh, then the mesh count will go up and we will unnecessarily require large computational power and time to solve the CFD problem. All these unwanted complexity do not even improve our CFD accuracy. Hence, these unwanted complexities need to be avoided. That can be done using the defeature tool. The defeature function in 3D CAD helps you to remove unwanted features from a geometry. Unwanted features can include holes, protrusions, chamfers, and fillets. The defeature function can also merge divided surfaces into a single surface. Till now, we have seen how to create CAD for CFD inside *CCM Plus. But when you do a CFD project in *CCM Plus, it is not mandatory to create CAD model inside *CCM Plus itself. In industry, various other popular CAD software are used, like SolidWorks, Pro-E, CATIA, etc. Hence, most of the times when you do CFD analysis project, you will receive CAD geometry from some other third-party CAD software. 3D CAD allows you to import geometry from many different formats into *CCM Plus. We have to modify this geometry before we run simulation using it. We can use the defeature tool and various other volume extraction tools. Let us see what all third-party CAD geometry formats can be imported into *CCM Plus. We can import following list of file formats: Parasolid transmit files, which will have a .xt or .xb file extension; IGES files, which have .IGES or .IGS extension; step files, which have .step or .stp extension; VDA files, which have .VDA extension; Pro Engineer file, which have .prt or .asm extension; CATIA v4 files, which have .model or .exp or .session extension; CATIA v5 files, which have .catpart or .catproduct extension; SolidWorks files, which have .sldprt or .sldasm extension; Unigraphics NX files, which have .prt extension. Now, when we import CAD files from external third-party software into *CCM Plus, we cannot just use them as it is for CFD. Various operations are needed on that geometry in order to make it suitable for CFD. There are many operations, some of which we will discuss here. In some cases, we will need to add or remove features from an imported model by creating more geometries in *CCM Plus. We will also need to use the extract volume feature. In some cases, the volume to be extracted will be internal and in some cases external. The Defeature tool is also helpful in deleting unwanted bodies. You can use the extruded and revolve cuts to remove unwanted parts as well. There is also the imprint option, which helps to imprint a profile on surfaces. So we have to use a combination of all these tools and operations to produce a CFD volume from an imported CAD model. We can also export geometry from 3D CAD. Although this operation is used lesser times, the export option allows us to export solid and sheet bodies in a neutral CAD format. As said before, for most of the CFD analysis projects, we import the CAD model from third-party CAD software. For this, there are some inbuilt plugins in CCM Plus known as CAD clients. We can import CAD geometry into CCM Plus directly from a CAD package by using any of the following supported CAD clients: StarWorks, StarCAD 5, Star NX, Star Inventor, Star Pro E, Star Creo, and Star Space Claim. What is the terminology called surface mesh? This term is very commonly used in CCM Plus. A surface mesh is a representation of the imported geometry. It consists of discrete representation. It is also used later to generate volume mesh. Most of the times, this surface mesh is made up of faces, which are triangles and vertices. These come from the pre-processing packages that we use for creating the CAD model. There are some preferred conditions for the surface mesh of a CAD model. The surface mesh must be closed and it should not contain free edges or any mismatches. An edge of a surface mesh should not be shared by more than 2 triangles. The surface should not have any self-intersection. The better the quality of the triangles in the surface mesh, the better the surface mesh. Ideally, equilateral triangles should be there. There should be gradual change in the size of triangles. There should be less sharp angles and surface folds. We have to ensure that the quality of the surface mesh should be good if we need to get better volume mesh in less time or steps. If we have no other option than to use a poor quality surface mesh, there is an option to use the surface wrapper or surface remesher. Let us see what is neutral format data in case of CAD models. Neutral format data files allow CAD model data to be exchanged between different programs while still maintaining the model integrity. They contain an exact description of the geometry of the individual regions that are used for the volume mesh generation. Surface meshes, on the other hand, contain a discrete representation. Another important concept is the native CAD data. Native CAD data files are created with parametric based CAD programs and contain all the relevant solid model information for that program. The model information can be read for each of the supported file types and converted into individual regions that can be used for surface and volume meshing. An additional reader license specific to each CAD program format is required in order to read the native files. What is XML data? XML files are top-level data files that typically describe the assembly structure and components of a product. It contains references to other files that contain the actual surface data for parts. Currently, two different implementations are supported. A basic version for Medina files and a more advanced PLM-based implementation suitable for other file formats such as JT-Open. XML data provides a convenient method of importing hundreds of files into CCM Plus using a common set of options for each, while still maintaining the structural hierarchy of components within the original design.